Hi, I'm Brian. In this video we'll be covering rotating circular geometry, including circular spatial variables, motion variables for circles, defining unit vectors, and defining the position vector to the typical particle. First, we define our base vectors as usual, and then we need to define some vector from the origin to the center of the circle. For this general example, we'll assume that the center of the circle is moving with respect to the origin, and this vector will be dependent on time. However, this circle could also be completely stationary or moving up some incline or any number of geometric setups. Next, we have our theta defined from the horizontal rotating clockwise, and these two variables in blue are going to be our variables of motion for this problem and are going to help us build our position vector to the typical particle. Here we define our first spatial variable from theta by some angle phi. Then we have some distance r from the center of the circle outward. These are going to be our two spatial variables that'll get us from the center of the circle to the typical particle. When we have to integrate with respect to space, these will be the variables we have to integrate with respect to. For example, if we're integrating a full circle, we'll integrate from 0 to 2 pi, and then we can integrate from 0 to some radius we could define as capital R or some actual number. Here we define the angle between theta and the typical particle. That's going to help us define our unit vectors next. And then we can define our n vector out from the center of the circle, and then the m vector perpendicular to the n vector. So now we have, now we can see that our typical particle is r in the n direction from the center of the circle. So now here's what's going to happen when our circle actually starts rotating. At this particular position, the angle phi and theta are the same. And finally, we can define our position vector, which is going to be the distance from the origin to the center of the circle, and then r in the n direction. And since we have two spatial variables, our position vector should be a function of the two spatial variables and our usual time variable. This approach to setting up the geometry of a circle will be defined just like this for examples in the future with rotating circular geometry problems. And the rest of our problem-solving strategy will be similar to our typical rigid body approach, but now we have two spatial variables.